This video, we're going to talk about 9.1 supplemental examples. That was about sequences. So let's write an expression for the nth term of the sequence and then determine whether the sequence you have chosen converges or diverges. So negative 2 to 1, we're going to add 3. And then we're going to add 5, and then we add 7, and then we add 9, and then we would add 11, and so on. So we're going to so that's one way that we can think about it, but let's try something else, because while that might work, that's not an easy sequence for us to write right now. So let's look at this. If I add 3 to this one, I get 1, and then add 3 to this one, I get 4. Add 3 to this one, I get 9. Add 3 to this one, I get 16. Add 3 to this one, I get 27. That's starting to look promising. Okay, so if I take this and look at perfect squares here. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is, that should be 25. 22 plus 3 is 25. I get this list right here. So it appears that the nth term can be written as n squared and then minus 3. So say a sub n is equal to that. Starting with a sub 1. And so the limit as n goes to infinity of n squared minus 3. If we want to talk about if it converges or diverges, we're going to have to take the limit as n goes to infinity, and this diverges. So there may be more than one pattern that you see, but we need a pattern, if we can, that gives us an explicit formula like this. It was not wrong to see that we added 3, then added 5, then added 7, then added 9, and then added 11, and so on. But that's all tied up in this n squared term right here. So let's go ahead and look at the next one. Let's write the first 5 terms in this sequence, where a sub n is equal to 2 plus 2 over n minus 1 over n squared. So a 1. 2 plus 2 over 1 minus 1 over 1 squared is 2 plus 2 minus 1 is 4 minus 1 is 3. A sub 2 is 2 plus 2 over 2 minus 1 over 2 squared is 2 plus 1 minus a quarter is 3 minus a quarter is 12 minus 1 is 11 quarters. A 3 is 2 plus 2 thirds minus 1 over 3 squared is going to be 2 plus 2 thirds minus 1/9. Let's change everything to ninths. 18 plus 6 minus 1 over 9 is 23 over 9. A 4 is 2 plus 2 fourths minus 1 over 4 squared is 2 plus a half minus a 16th is 32 over 16 plus 8 over 16 minus 1 over 16. 40 minus 1 is 39 over 16. One more because it said the first 5, so this is 2 plus 2 fifths minus 1 over 5 squared is 2 plus 2 fifths minus 1 25th is 50 plus 10 minus 1 over 25 is 59 over 25. All right, let's look at the next one. Find the limit of the sequence here. Limit as n goes to infinity, 2n over root n squared plus 1 is going to be equal to limit as n goes to infinity of 2n times 1 over n square root of n squared plus 1 times 1 over the square root of n squared. Since this is going to a positive number, I'm allowed to do that. And this is limit as n goes to infinity of 2 over the square root of n squared plus 1 over n squared is limit as n goes to infinity. 2 over root 1 plus 1 over n squared is going to 2 over root 1 plus 0 is equal to 2 over root 1 is 2 over 1 is 2. And so this sequence converges because it has a limit. That limit is not infinity or negative infinity. For the fourth one, find the limit of the sequence here. Limit as n goes to infinity, cosine of 2 over n is approaching cosine of 2 over n is going to 0, and this is going to 1. So that converges. And then we have determine whether the sequence is monotonic and whether it is bounded. So a sub n is equal to 2 thirds to the n. So this will be a monotonic sequence. Let's look at a sub n plus 1 is equal to 2 thirds to the n plus 1 is equal to 2 thirds of 2/3 to the n is 2/3 of a sub n. So if I'm taking 2/3 of this positive number here, I'm getting a smaller positive number all the time. So this is always decreasing. And so it's monotonically decreasing. You want to see the picture of this, what the graph looks like when n is 0, a sub n is 1. When n is 1, we're going to have 2/3, and then 2/3 of 2/3 is 4/9, and then we're going down, so on. So this is exponential decay, getting closer and closer to this horizontal asymptote of y equals 0, like that. And let's see, 2 4/9, so 1 2/3, 0 1 2 4/9, 3 8/27, and so on. So it's bounded below by 0. So that means that it converges based off of our theorem. And then that'll be it for this video, and we'll come back next time and look at some more supplemental examples from 9.2. See you for the next video.